Most books about large language models try to explain them with walls of math, equations, matrices, summations, and your eyes glaze over by page 10. But there's one book that does the opposite. It explains how these models actually work using almost 300 hand drawn pictures. No heavy math, just diagrams that finally make it click. It's called Hands on Large Language Models, and it might be the single best way for a normal human to actually understand AI from the inside. There's one catch, it's over 400 pages. So here's the deal. In the next few minutes, I'm going to walk you through the whole book, the big ideas, the pictures that matter most, and the one mental model that ties it all together. I'll tell you honestly who should read it and who should skip it. And at the end, I'll show you how to run every example completely free. Let's get into it. First, who wrote this and why should you trust it? This book has two authors, and the pairing is almost perfect. The first is Jay Alammar. If you've ever searched for how transformers work, you've probably read his blog post, The Illustrated Transformer. It's used in courses at Stanford, Harvard, and MIT. And it's the reason a whole generation of engineers finally understood attention. He's now a director at Cohere, an AI company. The second author is Maarten Grootendorst, a data scientist who built some of the most used open source tools in this space, including BERTopic for topic modeling. So, you've got the person who made the most famous visual explainer of AI, teamed up with the person who builds the actual tools. The book came out in 2024 from O'Reilly, runs about 428 pages, and Andrew Ng himself called it a valuable resource for understanding the techniques behind modern AI. This is not a hype book, it's a how it works book. Here's the mental model that holds the whole book together. Most people think a large language model is just one thing, a chatbot that types back at you. This book argues it's actually two different families of models, and you need both. On one side, you have generative models, the GPT family, models that produce new text. That's the side everyone knows. But on the other side, you have representation models, the BERT family, models that don't write anything. Instead, they understand text and turn it into numbers. You can search, sort, and cluster. Half the real world value of this technology lives on that quiet second side, and almost nobody talks about it. So the book is built in three parts. Part 1, understand how these models work under the hood. Part 2, use models that already exist without training anything. And part 3, train and fine tune your own. Understand, use, train. Let's walk all three. Part 1, understanding the machine. And it starts with the most important idea in all of AI. A model never actually sees words. It can't. So the first thing it does is chop your text into tokens, little fragments of words, and then turn each token into an embedding. An embedding is just a list of numbers, a vector, that pins the meaning of that token to a specific point in space. And here's the magic the book makes you see. Similar meanings land close together. The word king sits near queen. Paris sits near France. Meaning becomes geometry. And once meaning is just numbers, you can do arithmetic with it. There's a famous result the book builds on. Take the vector for king, subtract man, add woman, and you land almost exactly on queen. That came from early word vector research, but it's the perfect picture of what embeddings really are. This single idea, words become vectors, meaning becomes distance, is the foundation everything else is built on. So if a model only sees numbers, how does it write a sentence? That's chapter 3, looking inside the transformer. And this is where Alammar's gift for pictures really pays off. The key idea is a mechanism called attention. When the model reads a sentence, attention lets every word look at every other word and decide which ones actually matter for what comes next. In the sentence, the dog didn't cross the street because it was too tired. Attention is how the model knows it means the dog, not the street. And then the second big idea, the model writes one token at a time. It predicts the next token, adds it to the sentence, then reads the whole thing again to predict the next one, over and over in a loop. That's it. That loop, riding on top of attention, is the entire engine behind ChatGPT, Claude, and Gemini. The book draws it out step by step until it stops feeling like magic and starts feeling like machinery. Now, part 2, using these models without training anything. And the first lesson is the one most people miss. You don't always need a model that talks. Chapter 4 is text classification, handing the model a piece of text and getting back a label. Is this review positive or negative? Is this email spam? Is this ticket urgent? You can do it with a generative model by just asking, or often better and cheaper with a representation model that was built for exactly this. Then, chapter 5 goes a step further into clustering and topic modeling. Imagine you have 50,000 customer reviews and no idea what's inside them. You turn each one into an embedding. Let similar ones group together automatically, and out fall the hidden themes. No labels, no manual reading. That's the BERTopic approach from the very person who built it. This is the quiet superpower of AI that nobody posts about, turning a giant pile of messy text into structure. Chapter 6 is the one everybody actually came for, prompt engineering. And the book treats it as a real skill, not a bag of tricks. A prompt has an anatomy, instructions, context, examples, and the format you want back. The big technique here is giving the model examples right inside the prompt, so it learns the pattern on the spot without any training. Then, chapter 7 turns the model from something that answers into something that acts. This is where agents and tools come in. Instead of just replying, the model can plan out a task, call a tool like a calculator, a search engine, or your code, look at the result, and decide what to do next. It becomes a worker, not just a writer. And the book is honest about the trade. Every tool you hand an agent makes it more capable and harder to keep on a leash. But notice the pattern. Everything so far is still just clever prompting. You haven't touched the model's brain yet. Chapter 8 is, for a lot of readers, the most valuable chapter in the entire book. Semantic Search and Retrieval Augmented Generation, or RAG. Here's the problem it solves. A model only knows what it was trained on, and it can't read your private documents. RAG fixes that. First, you take all your documents and turn them into embeddings. Remember, meaning becomes geometry. When a question comes in, instead of matching keywords, you search by meaning and pull back the chunks that are actually relevant. Then, and this is the trick, you hand those chunks to the generative model and say, answer using these. Suddenly, the model can talk about your data, your company, today's information, and it's far less likely to make things up. Search to find the truth, generation to phrase it. The book also covers re-rankers to sharpen the results. And then, chapter 9 extends the whole idea to multimodal models, ones that can see images, not just read text. Now, part 3, the deep end. Training and fine-tuning your own models. And here the book makes a point I wish more people understood. You probably don't need to do this. Most problems are already solved by prompting and RAG from the chapters before. But when you do need it, this is the most powerful lever you have. Chapter 10 shows you how to create your own embedding models using something called contrastive learning, basically teaching a model by showing it pairs of things that should be close and things that should be far apart. Then chapters 11 and 12 cover fine-tuning the two families of models you met at the start. First, the representation models, the BERT side, for sharper classification, and then the generative models, the GPT side, to change how they actually write and behave. The ladder of the whole book is simple. Prompt first, add retrieval next, and fine-tune only when you truly have to. So, why is this the book I'd hand someone out of all the LLM books out there? One word: pictures. Almost 300 custom illustrations in full color, carrying the explanations. Most AI books make you fight through notation to reach the idea. This one shows you the idea first, then lets the code make it real. Because here's the other half: it's called hands on for a reason. Every single chapter comes with a runnable notebook. You read how embeddings work, then you open Google Colab and watch real words turn into real vectors on your own screen. Concept, then picture, then code you can run. That loop is why it sticks. It's also unusually complete. Most books only teach the generative, chatbot side. This one is one of the very few that takes the representation side just as seriously as search, clustering, classification, the stuff that quietly runs in production everywhere. Alright, here's my honest verdict. Who is this book actually for? It's perfect if you're a developer, a data scientist, or a genuinely curious person who's tired of hand wavy explanations and wants to truly understand how this technology works and build with it. If you learn by seeing and by doing, this might be the best AI book on the shelf right now. But let me be fair about who should skip it. If you want deep mathematical theory, the proofs, the derivations, the academic treatment, this isn't that book, and it's proud of that. If you're a non technical reader who never wants to see a line of Python, the hands on half will be lost on you. And because the field moves so fast, a few specific model names will age. But the core ideas here: tokens, embeddings, attention, retrieval, fine tuning, those are the evergreen foundations that won't change. This is a build your intuition book, not a reference manual. Read it to finally get it. So, how should you actually read it? You've got a few good paths. If you're brand new and you just want to understand read part 1 slowly, chapters 1 through 3, tokens, embeddings, and the transformer. Honestly, those 3 chapters alone will put you ahead of most people who use these tools every day. If you're a builder who wants to ship something useful this week, jump to part 2, so prompt, engineering agents, and especially the RAG chapter. That's the part that turns into real products. And if you're an experienced engineer who wants to train and customize models, part 3 is your home. Embeddings, fine tuning, the works. One tip every reader agrees on: web. Don't just read it. Open the notebook for each chapter and run it. This is a book you do, not a book you skim. Read a picture, then run the code under it. Finally, where do you get it and what's free? Hands on Large Language Models by Jay Alammar and Maarten Grootendorst is on Amazon and on the O'Reilly platform in print and digital. But here's the free part I promised. The authors put every single code example on GitHub. In notebooks you can open in Google Colab and run for free right in your browser. No setup, no GPU, no cost. You can literally read a concept and execute it 30 seconds later. It's one of the most generous companion repos in all of AI. And most people don't even know it's there. And to make it even easier, I built a free 1-page cheat sheet. Every part of the book, the core ideas, tokens through fine tuning, and the read it by your role map, all on a single page you can pin above your desk. Want it? Just comment the word illustrated and I'll send it straight to you. If this breakdown helped, do 3 quick things. Subscribe here on YouTube and follow Hyperautomation Labs on Facebook and Instagram, where I break down AI like this every day. My deeper paid guides are linked below if you want to go further. This is episode 2 of the series, so tell me which AI book I should read next. Now go build something. See you in the next one.